tbs96 for inviting Newtec to this event, and all of you for coming to hear it. I will present very quickly the company because it's our first time here in this event. Newtec is a satellite communication company. We are in business already 27 years. We are very active in the DBBS standard, and also we are very active in the research and development framework of the European Space Agency. Therefore, we have a history full of milestones of being the first to apply a lot of new technologies and advanced technologies. For example, right now we are leading the DBB S2 extension the standardization, where three things will be added to the standard. The first thing is the lower roll-off, so we can apply 5, 10, and 15% roll-off to the DBB S2. The second thing that is coming is that we will have much more and better modulation and coding schemes. You see here in light green the DBB S2, where you have around 28 modulation and coding schemes. In orange, you will see the new DBB S2, where you see there is a lot of granularity. We will have around 188 modulation and coding schemes. And the third thing that the station will bring to the standard is the addition of the 64 APSK. Okay, what that means for you in the practical terms, if you are running uplinks in distribution that normally works in this zone of carrier to nose, that means that you could have 27% more capacity available. This is a lot. Huh? For those who are using satellite transmission, is quite a high number. And for those who are more in the contribution with carrier to noise ratios of this, it means that you could get up to 37% more services in your capacity. Okay, the standard is not just closed, but we have already new platforms that support this technology. We have this modulator for broadcasting market, and this for the IP data market. So we are covering in the IP data market for the very low data rates up to the very, very high data rates, up to 380 megabits per second. Okay, about our manufacturing, we are manufacturing all our equipment in Belgium. That is somehow important for customers here in Albania because that means quick delivery times, quick repair times, less transport cost, and less customs cost. Anyway, we are present in all the world. We have 8 commercial offices around the world. We have 6 repair centers around the world, and we have a global distribution network. For example, here in Albania, we work with tbs96. Okay, about the market-wise, we are present in the broadcast, in the data IP market. In broadcast, we have products fitting in the contribution application and also in the distribution, both for the direct to the home or digital terrestrial television. In the data and IP market, we have the high-end products for IP trunking and telco backbones, and also a VSAT platform that covers from the very low data rates up to very high data rates. And we have also special applications for the government, security, intelligence. Okay, very quickly on the broadcast, just letting you know that we are able to provide the whole chain from the encoding up to the HPAs. So we are able to provide modulation, combining, up conversion in CKU, TBS band, and also if needed, the demodulation part. Specifically, for the DTT, we have a family called Horizon that is based on our Azimuth, our broadcast family, plus two things. We have an stream aggregator in the hub, in the uplink, and in the towers we add the multi-stream receiver. So that we have a solution where in the hub we add up to 6 multiplex, and in the towers we are able to extract up to 4 multiplex. That allows us to have a solution with 4 main benefits. The first one is that it's an easy to deploy solution. The second is that it requires very reduced capital investments. It reduces the operational cost and is SFN compliant. Going into details, the first benefit is once that the solution is in place, the adding of new services is quite easy. Just you have to put the next multiplex at the input of the stream aggregator, and you get out in the towers without any further hardware requirement. So, in the case that there is several multiplex, it is not needed to have one modulator per multiplex and one receiver per multiplex. It's just needed one modulator and one receiver in the towers, which reduces a lot the investment cost. Also, being operating in a one carrier environment and not in multi-carrier environment allow us to operate the uplink in saturation, what means savings, additional savings up to 12%. And the whole solution is SFN compliant. You can have the coverage of the country, even having different cells served by radio links or fiber, and other cells served by satellite, and having all of them in one SFN cell. And also, we provide security for the content. We provide the AES encryption that is also SFN compliant, that is more secure than other solutions that are available. So in the same solution with the aggregator, the modulator, and the receiver is embedded the security. Also, the solution has a network management system embedded, so it's possible to manage and to monitor and control all the elements of the solution, the hub, the receivers in the towers, and if they are not available, a return channel for control, monitor and control, it's possible to add our VSAT solution to get all the data back to the control center. Okay, some examples of our networks. We have in Italy La Sete, where they are uplinking up to 4 multiplex. We have as well in Bulgaria a big network of 700 towers, where they are uplinking 3 multiplex, and they have in the towers 1+1 redundancy solution. We have also the network in Greece, where they are uplinking only 1 multiplex, and they have a standalone solution in the towers. So, and now I give the floor to Jean-Luc to explain you further our products.
So good morning. I will present you now our new modulator, so the M6100. So here you can see the new front panel, so with different buttons to be able to control this part of the LCD screen. Here we have navigation path. So we have an Ethernet front panel that you can, so you can directly access the GUI from the front panel. Here you have some status LEDs, so active alarms, non-pending alarms, transmission on or not, and the input on or not. The back panel, so of course you have the power supply. We have IF and L-band together, so it's just software enabled. So the L-band output is between 950 and 2150 megahertz, with an output of +7 dBm, and the RF output, so between 50 and 180 megahertz with plus 10 dBm. Here we have two ASI in and two ASI out, so you can have a dual monitoring on the output, and of course you have a redundant ASI input. Here we have two data traffic Ethernet ports and two management Ethernet ports. So you have of course redundancy, and you can use it for the monitoring via SNMP traps. Here we have the serial ports for the redundancy, which can be used too with the IP port. And those two here, it's a reference in and out for the 10 megahertz clock. So what it does actually, S and S2 compliance, up to 32 APSK, 68 megabaud. Of course, short and normal frames, so it's all DVB-S2 standards. So the default 10 megahertz reference input, so we have it by default. Before it was an option, now it's a default setting. And internal reference clock with high stability options. So the new features that we have, which are part of future DVB-S2 extensions. So clean channel technology. We have our tool, which is the equalink pre-distortion. I will explain you after what it is. We have ASI and gigabit Ethernet inputs with port redundancy. So we can do unicast and multicast over RTP or UDP. We follow also the FEC for SMPTA 2022. So it's a pro-MPEG thing. And we can do, of course, opportunistic or fixed rate IP for it. So to distribute video on demand, set-top box upgrades, etc. So capabilities that we have. So we have embedded a transport stream analyzer that we'll see later. Carrier ID injection. So for the moment in the need tables, but later on the RF part. So transport stream rate adapter. So compliant with SFN network. So redundancy. We have a pseudo-random generator, so you don't need especially a link transmission, a real transmission to do it. You can use this generator. And we can monitor so all the different parts, the inputs and outputs. So first, the equalink. So when we transmit over satellite, so on the transponder, you can have some distortion at the transponder level. So the amplifier is generating some amplitude or phase distortion. So what we do is that we do a pre-distortion of the signal to get a perfect constellation at the receive position. So how is it done? We transmit so the signal. We receive it with a demodulator. We measure the received signal. We analyze it. We autocorrect the input signal, and so on and so forth until it's stable and that we get the pre-distortion of the signal. So what it does is that it can give you some additional channels if you can have more megabaud without degradation, or you can have a more robust signal over the footprint. Or if you can go to more megabaud, you can add more carriers, so SD or HD carriers. So carrier interference. So this has been asked by the satellite operator because they have some everyday problems. Some people are transmitting over existing signals and creating problems. They are blocking the existing signals, so you cannot transmit anymore the channel. So what they ask is to add something. Okay, add something just under the noise floor, so you can have information about the signal itself. So you can add the vendor brand, the MAC address, the serial number, and you could add as configurable data the GPS coordinates, the telephone number, the responsible person. So you could find the person that is transmitting or on the wrong frequency or doing it on purpose to block the channels that you are transmitting. So in the modulator, we have the transport stream analyzer. So we can measure following the standard DVB TR 290. So you have several priorities, and it's checking that you don't have any problem on the transport stream if you are losing the sync or things like that. So we can do transport stream restamping and transport stream pass-through at MPEG level. So we have forward error correction, so following the SMPTA 2022. So it's especially used if you have a video headend which is not near the modulator, so you have to go through IP. And at that moment, it's checking that the integrity of the stream that you are transmitting is OK. So we can do data transport via multi-protocol encapsulation. So you can have a video transport stream and some data which are MP encapsulated and transmit. So it helps to have two signals together, video transport stream plus data. So here we have some other equipment, which is redundancy switches. So it's new switches that we have. So now it's up to 16 plus 1. The previous one were 8 plus 1. We can switch any entry and output. So SI, IF, L band, RF with C, KU, DBS band. We have IP logical switching. So it's easy to install and configure. So it's recognizing itself when it's plugged. So you have a GUI showing the graphical view of the switch you want to do. And it supports all the existing equipment plus the new equipment that we have. So this is an example of how it works on the 1+1. So you have an alarm arriving. So it's sent to the switch system, so which is transmitting and switching from the main to the backup box. We do some frequency converters. So the first one is an up converter. So IF to L band, and we could do IF to L band and after to C, KU, and DBS band. We have an up and down converter. So the same IF to L band and L band to IF and C, KU, DBS. We have a combiner of 4 or 8 inputs and 1 output. So the down converter on the right, which is L band to IF, and we have a last one, which is a dual input, so L band to C, KU, and DBS. So of course we can do redundancy on them. So equaling, yeah, you've seen. So it's an example of what we did with Sky in Italy. So they had a network with 20 transponders, 20 DVB-S transponders, and 15 DVB-S2 transponders. With the Equalink, we were able, without degradation, to go from 27.5 megabits to 29.9 megabits. So the gain in DVB-S was 3.3 megabits, and the gain in DVB-S2 was 4.6 megabits. So you can add SD or HD channel. So in total, with all the transponders they gain 135 megabits. So you can see how many channels you can put in that. And just by putting Equalink on the device. So the clean channel technology. So this is helping you to go lower in roll-off. So normally you have 35, 25, and 20% roll-off. Here you can go to 15, 10, and 5%. So the gain is because you can gain also steeper carrier slopes, and you can put some more megabits, so in finally more megabits in it. So here it shows what it does on the signal. So the first one is roll-off with 25%, so DVBS2. And so you see on the side that the side lobes are a bit high. And after when we put on the clean channel technology, you can see the effect of the tool, of the software. So it's an algorithm which is cleaning the side, so you have advanced filtering, so you have steeper slope and less noise on the top of the carrier. So here it's an example of a real carrier where we did test a few weeks ago. So in blue, it's the one which is without the clean channel technology, and in yellow, the one with clean channel technology. So it's the same roll-off, it's 20%, but you see the difference between the two. So you can put more adjacent carriers to make it working. And to finish, this is a tool that helps Equalink and to work. So it's a noise and distortion estimator, which is helping to measure the real link margin. So we have it on all our demodulators. So when you inject some power, so you arrive up to the end of the linear zone. So you have a standard power distortion. And on the right, you can see without node and with nodes the signal, how it's measured. So I put a bit more power. So I arrive to the optimum point. So you can see you have a bit of distortion. You have the optimum power. And on the measured level, so you see without nodes that you have a bit more margin because you add some distortion in it. And with the node tool, so you can really see your real margin, and you can see if you can increase or not the power to the real optimum level. And if I continue to inject some power, so there, of course, it looks like without node we have a beautiful margin, but in fact you have nothing because you just do distortion, that's all. Okay, if you have any question.